Hey folks, welcome. Real quick before I get started, this talk is kind of aimed at the me of about 25 years ago. Some background development in other languages, new to Python, trying to figure how a lot of things work by osmosis. It's very much a beginner's talk, so if you're not a beginner and you're not a friend of mine, there's some really other great talks going on right now. You might want to sneak out. Like the resiliency talk looks really, really good to me. So. A little about me. Currently a site reliability engineer down in Columbus at Nationwide Insurance. Previously at Nationwide, I worked on our Kubernetes platform team. I was a technical lead for our secure software delivery team, doing things with supply chain security and software build pipelines. If anyone's seen the open source SigStore project, very similar to that, but internal. And an automation engineer using Ansible and Python to automate actual hardware servers in our on-prem data center. Python community, I've been doing Python since about 2005. Was lucky enough to do it full time for 2 long stretches, so 7 to 16 and 18 to 21. I'm a former organizer of the Central Ohio Python user group down in Columbus. I've been an organizer, staff member of US PyCon for a while. And I'm actually a former organizer of this conference, including having the honor as serving as the conference chair in 14, 15, and 16. Presentation today is slide driven. Not that I've ever seen anything go wrong with a live demo. But there are code samples illustrating these concepts in GitHub, the code that I wrote to steal the slide code from. So feel free, if you get a laptop, to go out there, grab them, poke around. They're just snippets of Python code illustrating the same things that we're going to talk about here today. All right. You might have heard that you can return multiple values from a Python function or method. Sadly, like many purchasers of parrots and cheese, you've been misled. But wait a minute, you say, Brian. I've seen code like this. I have a function. It returns 2 strings. Then I declare 2 variables separated by a comma. And I assign the results of my function to those 2 variables, and I print them out. And there's spam and eggs, right? It's multiple return. Well, not quite. See, that function actually returns a tuple. And if instead of having 2 variables that we assign the result to, we just have one capture the result of our same function and print the type of the object we get back, right? We see indeed that it is a tuple. So just a brief aside on tuple syntax. Thanks to my friend Alan down here who ran into this issue at work, so I decided to stick some of this in the slides. So here's a way we normally think of doing an inline tuple, right? There's parens around it, so we've got 2 ints and a tuple here, and print the type of that. You can see clearly that it's a tuple. Print the actual object itself, right? Once again, very straightforward. Here we're just declaring the same thing, but without the parens around it. So, which is the way when we return things from a function, we usually do it. And you can see it's the exact same thing, right? It's class tuple, prints out the exact same way. So it's actually the comma that makes the tuple. So here we actually have a single item tuple, right? String followed by a bare comma, it's a tuple. Well, except when you need an empty tuple. Then it turns out that the comma is just a syntax error. And if you want an empty one, inline, you just have empty parens. Now I'll say, I don't think I've ever done this in like 25 years of Python coding, except like in a talk or a demonstration for somebody, like creating an empty one this way. But that's the way that you do it, because of course, there should be one and preferably only one obvious way to do it. Although that way may not be obvious at first, unless you're Dutch. I'm kind of getting away from the point here. That is, right, we're only returning a single object, a tuple, when we do that multiple return. Then we are unpacking that tuple into multiple variables. And that actually works not just for tuples, but for anything that you can iterate over, as long as the sides balance. But why do we care? Like, why do we care that that's not really multiple return, but we're unpacking an object? And part of that is like our mental model of what's going on under the hood is important, and not having a good one can lead to subtle bugs. And hold that thought. We'll talk a little bit more about it later. Okay. So just some more examples, right? Here's the same function, except I'm returning a list now. And you see we have the same unpacking syntax. Two variables on the left side, assign it to the result of the function, we get two things out. Same thing with a dictionary, right? When you do this over a dictionary, you just get the keys, so it actually works the same way. Once again, doing the same assignment, get the strings out. Or I can actually call items on the dictionary and do the same unpacking. Instead of looping over it, now I'm actually getting tuples out, right? More on that later, because that's actually how looping a dictionary works. But just keep going with some more examples, or just demonstrating this pretty much works for anything that's a sequence, right? Here we're just generating a range. Pull it out, same deal. And a generator. So if you've ever encountered generators, or especially if you're not, right, this is a way to do a function that lazily evaluates. You can loop over them, and they produce results. And if you have a finite generator and you know how much stuff is in there, instead of looping over it, you can do the same kind of sequence unpacking assignment. Okay. That unpacking, as I said before, is how looping over a dictionary works. So here's typically what you do when you want to loop the keys and values in a dictionary, right? For key value and order items, print the key and the value. But if you run that same loop and just bind to a single variable, then you can actually see the tuple coming out. So when you're doing these things, right, you are using this unpacking syntax against tuples under the hood. Okay, more fun, complicated things you can do with this. You can actually, there's a fairly elegant syntax you can use to unpack nested data structures. So, I don't know, that might be hard to see from the back of the room, so I've kind of blown it up in the next few slides. But what we basically have here is a nested list. So the outer list has two strings as the first two elements, and then another list as the third element. As we descended in that middle list, it also has two strings as the first two elements, and then another list as the third element. And our final inner list just has two strings in it. So we'll start kind of walking through unpacking this, right? So nested list in mind that we just used, first, second, and third, do the assignment, and if we start to print what we've got back, right, the first is just our first string, the second is our second string, and that third thing is the middle and inner list, and all its parts and pieces. But if we change our syntax here, right, so now we have F and S, pardon the C variables, it's getting hard to fit everything on the slide. So F and S for the first and second, and now where we had that third, right, we have a set of grouping parentheses and three more variable names. And so what will happen here, right, so if I print my F and S first and second, those are just those two strings, the first two strings in that outer list. But now the middle list, sitting in that third place, we've unpacked it. And so into those variables. So now I can see there's my string from the middle list, there's a second string from the middle list, and that empty third item is the list all the way at the bottom. Make sense to folks? Keeping on going, right? We can actually wrap another set of nesting parens in that statement, and now we're pulling everything out and flattening it. So I didn't repeat everything, but we're just looking at the last two things in that innermost nested list, right, and pulling them out and printing them. And we get those two strings, right, the two strings that were here. So it's a very elegant way to extract things from nested data structures. Also want to point out that I was using parens there for the grouping. You can use square brackets as well. You might be thinking, what's the point? But the actual point is you can mix and match. So when you're doing more complicated statements, it makes it easier to see how your grouping goes, because you can alternate between the parens and the square brackets as you descend. And then if you're kind of thinking, well, why would I even want to do this? Because if you don't do this and you're trying to pull stuff out of nested data structures, then oftentimes you end up with things like this, where you're like doing an assignment and like having to dig into the structure with indexes or key names. And to me, this just looks a lot clunkier. Now, you can obviously go the other way. Like if your structure is really complicated and you've got like 8 zillion parens on your assignment on the left side, that's probably not good either. Okay, so let's talk about using the asterisk or star to capture subsequences out of things. So here I have the range operator. I'm just generating 5 integers, and I've got first, comma, star rest. And I print first, and there's my first number out. And then I print rest. What I've done is I've unpacked that sequence and then repacked all those things into a list. And doesn't matter where I use that, right? As long as everything balances, I need to have, you know, I can't have more variables on the left than the thing that's on the right. And I can only use one star. So only one of those variables can be starred in this kind of expression. But Python will figure out like what I want to do, right? So I did first, star for the middle, and last. As you can see, Python pulls that first number out and sticks it in my first variable. It pulls the last number out and sticks it in my last variable. Everything else gets grouped to the middle. And obviously, same example with last, right? I can get the first 2 out, cram everything into last. We can keep going. Right here, I've got 4, first, second, extra last, and it grabs the 2, 3 that are in the middle of that chunk and sticks them in that list. You can kind of mix and match those two things. So if you remember this, when we were flattening the nested list just a few minutes ago, the MF and MS were the first 2 strings in our middle list. I can actually star extra there. And now when I pull that structure out, I've repacked those 2 things into a list. It's just another way that you can kind of elegantly rework data structures. You can also use that syntax or that star syntax to do unpacking as well as packing in the right context. So here, we're going to use it to unpack some things in a function call. So I've got a simple function here, just takes 3 arguments, prints them out, right? If I have a list, or really any sequence, right, I can pass the name of that thing into the function with that star. It will unpack the list and map them onto my positional variables. So rather than having to call the function and say like data, once again, indexing, data 0, data 1, data 2 to get that list mapped onto my function, I can just use this syntax. It will unpack the list, map them in order to those arguments. Just repeating the example with the range argument to see it doesn't matter, doesn't have to be a list, anything that's a sequence where the sequence matches the number of arguments here works. This works for keyword arguments too, right? So I can declare keyword arguments here. If I just print it this way, right, I'm just getting the defaults out. But I can make a dictionary, and this time I'm using double star to tell it I want to unpack the keys values of that dictionary, and it will unpack that dictionary and map those keys and values onto my named keyword parameters in my function call here. Notice, right, you'll see sometimes, and we're going to hit this in the next section, you'll see functions defined where some of the parameters have a star or a double star in front of them. That's not what we're doing here, right? You don't, to use this unpacking, it is not required that your function signature have those unpacking or packing symbols in them. You can just use this with any function definition. Now, the other way, right? Args and kwargs, or sometimes people say args and keyword args. right, is you can actually use this syntax to basically collect any extra arguments that are passed to the function that are not explicitly declared, right? And also by convention, we usually call these actual names, args and kwargs. The names aren't magic, the asterisks are. So you can actually call these any variable, but please don't. It's a long-standing convention to call them this, and people are looking for it. And if you call them something else, they're trying to figure out what weird thing you're doing. So here we go. Simple function. There's 2 positional arguments, and then we have args here with the star. Basically says, if you give me extra positional arguments more than 2, collect them in a variable named args. So if we actually run that function, right, and pass 4 things in, print them all out. So you'll see spam eggs, those were my 2 positional arguments that I declared. The rest of the positional arguments get gathered up into a tuple. And it is just a tuple, so I just printed it out as a whole tuple here so you could see what it was, but you can index into it, iterate over it, whatever you want to do to pull that data out of it. But it lets you pass extra arguments into a function and deal with them. Once again, you can do the same thing with keywords, right? So declare a function that takes keyword arguments, and this time I have the double asterisk notation there. And when I call that, right, it will basically pack any extra things I give it into a dictionary and hand me that dictionary with the name kwargs. So I can get it at those variables. So functions or methods, putting it all together, right? You can use both of these techniques together. 2 common places that you will see them in Python code is decorators and in class inheritance. So, and you're seeing it less and less in class inheritance, especially now that we have type hints and everybody likes to do type linting. I'm not saying this is necessarily a good idea, but I am saying you're going to see this code in the wild, especially if you're looking at code in older Python libraries and try to figure out what it does. So we're just going to kind of walk through it here so you understand what's going on. So I have a simple class, right? It takes a couple of positional arguments, and it takes a keyword argument. I'm going to have another class that inherits from that. And this class takes an additional keyword argument that the parent class doesn't know about. So to make things work right in Python, I have to do the initialization code in the child and then call the initializer in the parent. And what I want to do here is pull out the thing that only the subclass cares about and make sure I pass all the rest of the arguments onto the parent class. Now I could name them all and just pass them in that way, but this is just a shorthand for doing that, right? So my subclass only really cares about whether or not I want some rat in my breakfast. Monty Python sketch, if you've never seen it. The args and kwargs here in the init part up here collect the extra args that I'm going to pass when I basically call this class and initiate the object. But then they're going to turn around and pass them, right? So here, up in the first part in the init, we're essentially packing those extra args into those things. And then when we call the parent class's initialization, we'll hand them those same arguments and let the parent class unpack those things. So we just don't have to keep track of the names of stuff that the parent class cares about. It's just a nice little shorthand for that. But if you rip back real quick, right, this only cares about some rat, right, as it's written. Everything else just flows through. But if we actually initialize one and pass it in some stuff, just print SB, you can see it's the second breakfast object. When I dump the variables, you can see everything, right, from it and the parent, including the fact that we actually changed one of those values. So now I want to talk just a little bit here. I mentioned this at the beginning about like mental models and why I think it's important to understand a little bit about how this stuff works under the hood and not just kind of use it by osmosis. And I'm going to start out just talking a little bit about driving a car, because it's a pretty simple mental model that everybody, I think, understands. Even if you don't drive, you have some idea, right? You got the wheel that turns it, pedal on the right makes it go faster, pedal immediately to the left slows it down. You have a shifter or sometimes flappy paddles, and if it's a complicated enough shifter, you might have a third pedal, right? And that's enough, right, for you to use the car. Now, if you're a NASCAR driver, you might have a much richer mental model of that car. If you're the engineer and mechanics that build the car, an even richer one than that. But it's, right, it's more or less the same model. But now you're flying in your buddy's small plane, and he passes out, and you have to take the controls. And if you apply the mental model of your car to the airplane, you're going to have a really bad time, because that yoke and the pedals and the little things that look like shifters down on your right don't do anything like they do in a car. So, and so I'm going to talk a little bit here about a bad mental model for Python code that I've run across before out in the wild. I even saw this actually in a college textbook one time. And it's talking about the kind of unpacking assignment that we were doing right in the beginning. And this actually led to a production bug that I had to like figure out what the heck was going on and fix. But I would see the statement, right? It's a tuple of variables on the left and a tuple of values on the right. So we just kind of wander through some simple Python code examples here, right? I've got some simple assignments. B is equal to 2, A is equal to B, print them both out, right? They're both 2. Here, right, we're just going to inline all that. So A equals B equals 3, print A and B out, they're both 3. Let's put that together with that bad mental model statement we had a few minutes ago about, well, just a minute ago, right, about a tuple of variables and a tuple of values. And we're like, huh, does this work? Here, I've got a tuple, and I'm unpacking it, and I'm printing the individual variables. That works as expected. Then I assign the entire tuple to a variable, print that out, comes out as a tuple. So can I inline that the same way? Group equals ABC equals the tuple. If I print them out, right, I've got 1, 2, 3, and I've got the tuple. So this seems to actually kind of work, right? I've got a tuple of variables on the right, and then a tuple of values in ABC, and then I assign those to a group, and it's a tuple. Like, we're all happy here. So let's introduce a generator, right? So I've got a little finite generator here that's going to yield out 3 values. And does this work, right, the way that, given that statement and the code samples we just looked at, the mental model that's built up in your head about how this might work? And so we say, let's, our group and our individual variables, and let's assign the generator, right? The generator, which yields 3 values out to ABC, and then that to the group, right? And we print ABC, and we got our numbers out, and we print group, and we don't have a tuple of our numbers, we have the generator object. Maybe we need some magic wrapping parentheses around that ABC somehow to make it a tuple. And yeah, that doesn't work either. And the worst part is, right, the generator that's been assigned to that group variable outputs nothing, right? And when I created it, it had 3 finite values in it, but if I try to loop over it, nothing happens. And generators are one use, and so once they're exhausted, if you try to loop over them again, they just act like an empty list, which in Python does not raise an error, the loop just never runs. So let's think about what might be going on here. And we're actually going to use the dis module to poke at some code. So dis is a module that disassembles Python code. So if you, in CPython, right, even though it's a dynamic language, when you run Python code, it is compiled to Python bytecode, and then that's what is actually run. And dis will disassemble Python bytecode. Another little nifty feature of it, though, is you can feed it Python strings. If your string is a valid Python statement, it will, behind the scenes, compile that snippet of code and then dump it for you. So we're going to go back to just our simple assignment, a = 3, and we're going to run that through dis and look at what we get out of it, right? Grayed out the stuff we don't care much about. And the thing we care about, right, is we see that load constant statement for the 3, and then we see store name, which binds it to A. So let's go to our A = B = 3 inline. And now we might start to get an inkling of what was happening to us here, right? So we load the constant, and we copy it, right? Which here is a reference copy. We're not copying the object, right? And then we store the name twice, but it's the same object. It's the same 3. And that's kind of a hint as to why things went astray with our generator. Because if we look at the generator example, the same basic thing is happening, right? I'm not unpacking that generator to ABC, which then becomes a tuple that I assign a group. I'm actually putting the name of that generator on the stack. I'm calling it, which creates that generator object, and then I copy the reference. So now I have 2 references to the same generator. Then I unpack sequence, which is what you see in dis when you do the kind of sequence unpacking that we've been doing here for the last half hour, which runs the generator and stores its values into my ABC variables. And now group is also pointed at generator, which is exhausted, which is why way back I expected some code to do something, and it was just an empty loop doing nothing until I figured this out. So that's pretty much it. Not a great wrap-up ending here, just wanted to go through and do some sequence unpacking and dig a little bit into what's going on under the hood, both to hopefully teach some folks some more elegant syntax they may have not seen before, and to just kind of let